rate of change, one of the biggest ideas in mathematics, one of the biggest ideas in algebra. You're going to see this come up over and over and over again. You're going to see it in geometry. Rate of change is not going to disappear anytime soon. So it would do you well to learn this well. I'm going to show you a bunch of different contexts that we talk about slope. But in every context, we're really talking about the same thing. We're talking about a distance that is changed vertically, so up and down, divided by a distance that's changed horizontally. Okay, sometimes I write it like this: vertical change divided by horizontal change. All right. So the first context that you could look at is an inclined plane or a ramp. Literally, you would just be measuring the height, how far up do we travel, and dividing that by the length of the ramp. How far from left to right do we travel? So if these were our dimensions, our slope, our grade would be 3/16. Okay? Keep in mind that when we're talking about ramps or inclined planes, usually we consider our slope to be positive, but technically, if we want to be consistent with the rest of our mathematics, if from left to right we're traveling downward, we want to call that a negative slope. And if from left to right we're traveling upward, we want to call it a positive slope. Okay, that's context number one, inclined planes. Context number two will be the coordinate plane. If you are given a line in the coordinate plane and you're asked to find the slope, there's a couple different ways to get that information. Most common way would be look for 2 points that you know are on that line. So you're going to be looking for situations like this where you can see exactly where the white line crosses the grid lines. Create a little triangle for yourself, a right triangle that connects those points, and count. Right? This is a distance of up 1, and this is a distance of forward 3. My slope is how far did I go up or down, divided by how far did I go left to right, so 1/3 is the slope in that situation. Okay? We could also ask for slopes, not of lines, but between individual points. So what is the slope from this red point to that red point? And again, in this context, you can just make yourself a nice right triangle. So go straight up and down on the grid lines, straight left to right on the grid lines. Okay? Right triangle, and then count. All right, we're going down. 1, 2, 3, 4, 5, 6. Down 6. Okay? Please do remember, this is 0. Don't start counting with 1 there. I haven't gone anywhere yet. 1, 2, we're counting spaces. All right? Down 6, and then forward 4. And the purple slope, the slope from this point to this point will be then -6/4. Context number 3, if you're given ordered pairs and asked to find the slope between them, but you don't have a graph. All right, there's 2 ways to get this answer. For my people that like formulas, there's a formula that will give you a slope. All right, the formula looks like this. Slope, which traditionally we call m, equals y minus y1 over x minus x1. Sometimes people say y2 minus y1 over x2 minus x1. The real deal with this is you are saying I have two different points. So I have an x coordinate and a y coordinate. For my second point, and I have an x coordinate and a y coordinate for my first point. Okay, so this is x1, y1, and this is x2, y2. All right, so given that formula, we just put the numbers in. See what happens. So you'll have 14 minus negative 8 divided by 5 minus 3. Do your math. You can just use a calculator at that point. If you are just going to use a calculator, you have to remember that there are understood parentheses around the numerator and understood parentheses around the denominator. Okay? If you don't put your parentheses in the calculator will get the answer wrong. 14 minus negative 8 is 22 over 5 minus 3 is 2. The slope is 22 over 2 or 11. Okay, that's one way to get a slope. Use the slope formula. A different way to get the slope. My preferred method, maybe some of you will find it easier. Some of you will find it more difficult though, so you could use it either way. I like to make a sketch. So 514 and 3 negative 8. Okay. I don't put any grid lines on or anything like that. I do get an idea. I know that the slope is positive. I know that it's very steep. And then I just look, all right, how far is it from 3 to 5? It's 2. The distance from 3 to 5 is 2. So this little distance here is a distance of 2. How far is it from negative 8 to 14? Well, to get from 14 down to 0, that's a distance of 14. To go down 8 more, that's where I get my 22 from. All right, so this distance is 22. 22 divided by 2 is that slope of 11 that we got before. All right, so two different ways to get slopes if you have ordered pairs. Context number 4, tables. When I'm looking at a table, essentially I'm just looking at sets of ordered pairs. Column 1 will be my x values. Column 2 will be my y values usually. And I just have to pick out 2 rows from this. Right? I usually try to pick the rows with the smallest numbers. I try to pick rows that have positive numbers. They don't have to be rows that are next to each other. I'm going to show you how to do this with these 2 rows, and then I'll show you with a different set of rows. So the question is going to be, how are my values changing? Okay, in the x category, I'm going down 3 from 4 to 1. In the y category, I'm going down 6 from 6 to 0. Okay, and then my slope will be change of y divided by change of x. All right, that's another way to think of slope. So it's going to be negative 6 over negative 3, which equals 2 over 1, or just 2. All right, that's my slope there. Okay, if I had used a different set of rows, and I have a linear pattern, so let's say I used this guy and this guy, from 7 to 8 is up 1, from 12 to 14 is up 2, change of y, 2, over change of x, 1, the same thing. Okay, so it doesn't matter in a linear table, it doesn't matter which two rows you choose. To find your slope, you'll find the same slope no matter what. All right, no matter which two rows you choose. All right, that's context number 4, tables. Context number 5, sequences. We've actually already dealt with this. 2, 8, 14, 20, 26, 32. Slope in the context of sequences is going to be, what am I counting by? Okay? Plus 6, plus 6, plus 6. All right, this is my slope, or my rate of change. Rate of change for sequences is what number are we counting by? And context number 6, my favorite context, story problems. Okay? Story problems. If you have a story problem and you're asked to find the rate of change or the slope, you should have 2 different things that are changing in value. All right, in this situation, we have coins. All right, coins are going from one value to another, and we have dollars. All right, so figure out what's going on with my situation. Ishmael sold 3 coins for $12. 3 coins goes with $12. That's one of my ordered pairs. He sold 9 coins for $24. 9 coins, $24. That's another ordered pair. All right, anytime I have an ordered pair, I should be able to find a slope or a rate of change between them. Now, the ending question says that this rate of change, slope, how much would it cost to buy 30 coins from him? So that means what, if we have 30 coins, all right, coins came first, what will the cost be? Okay, so starting just with the first piece, let's find the rate of change. All right, we have y minus y, 24 minus 12, over x minus x, 9 minus 3. All right, I gave you guys a lot of slopes that equal 2 this time. 12 over 6 equals 2. 2 is the rate of change. All right, that means for every new coin that we're adding, we're paying $2 extra, right? $2 for each new coin. All right, so I could count up from 9 coins to 30 coins, or the other thing that I could do, and this gets a little complex, but I could say, now that I know what the slope is, now that I know that the slope is 2, let me use this point and this point that I have a question about. So 12 subtracted from something that I don't know has to, divided by 30 minus 3 has to equal 2. All right, and then I could use my operations to figure this out. So how do I know that 2 is there? Because we already found out with that red thing that I just erased, the slope is 2, right? So we have question mark x minus 12 over 27. That's 30 minus 3 equals 2. Let's multiply by 27 on both sides. X minus 12 equals 54. Let's add 12 to both sides. X equals 66, right? 66 bucks for 30 coins. The other way that I could do this is count upward from 9 to 24, right? 10. If my slope is 2, I should be going up 2 in the dollars when I go up 1 in the coins. Jump 10, 20 would be up 20 here, 46. 30, up 20 here, 66, right? Another way to do that, you don't have to count by tens either. You could count by ones. You would make a really big table. But there's lots of ways after you figure out the rate of change to find connections between numbers, right? All right, so this is what I'm going to do from this point forward. I'm going to put problems on the screen in the different contexts. I want you to hit pause, see if you can figure the slope before I do the slope, and then unpause and see if you've done it correctly. All right, when you feel like, yes, I've got the hang of this, then you're ready for your paperwork. We're going to call today time 0. So at time 0, the plant is 5 centimeters tall, and back 24 days ago then would be minus 24, negative 24, and at that time the plant was 2 centimeters tall. Okay, first question, what is its rate of growth? Rate of growth, rate of change, slope is just going to be change of y, so from 2 to 5, that's 3, divided by change of x, from negative 24 to 0, that's positive 24. That can simplify down to 1/8, or it could be as a decimal 0.125. If the plant continues growing at this rate, how tall will it be 15 days from now? I could add this value 15 times to 5. Okay, so 5 plus 15 days times 0.125 centimeters per day. All right, that's one way that I could do it. Or I could say, what numbers will give me 1/8 as a slope if I insert some number minus 5 over 15 days from now minus today. All right, so some number minus 5 divided by 15 should give me 1/8. Okay, I think that this way is going to be easier for me. Could just use a calculator to do it. I'm going to come out with 6.875 centimeters tall. Choosing 2 rows. Let's go bottom row and top row. So from 30 down to 22 is -8. From 9 down to 7 is -2. -8 over -2 is a slope of 4. (11 minus 23 on 13 minus -7 is -12 over +20, which is -3/5 or -0.6. Nine, 10, somewhere up here. 4, -7, somewhere down here. distance from 4 to 9 is 5. The distance from -7 up to 0 is 7, and then up to 10 is going to be 10 more. So 17 altogether. And we have a slope of 17 over 5. That could simplify down as a decimal to 3.4. Counting down by 5s, that's the slope. Forward 2, up 3, that's our slope. All right, choose 2 spots where you know the line is crossing grid lines. Then count. We're going down 2, forward 4. So it's a -2 over 4, or -1 over 2, or -0.5 slope. Choose 2 rows. So we'll use 610 and 1840. From 10 to 40, that's an increase of 30. From 6 to 18, that's an increase of 12. Dividing that, our final slope will be 5 over 2, or 2.5. All right, 2.5 is what you should have got.